So Firefox 45 was, I think, released in August of 2015, and we've seen a very steep decline in the existence of HTTP logins. And HTTP page loads are also slowly going down from, from initially almost 60% to now a bit under 50%, which is really good considering it's been such a short amount of time, right? So what's responsible for this change? In my opinion, it is, first of all, that browsers now start to aggressively flag insecure sites. So if this is your site, you probably don't want to have that label. That's what we currently do, or that's the one thing is what Chrome currently does, the other thing is what we, as Firefox, currently do when a page has a login field but is not using HTTPS. We're flagging that because the transmission of these credentials would be insecure, and so we want to warn the user, hey, this is not a secure website. There has been a lot of concern from the web developer community around these warnings. We have been getting a lot of bugs by people saying, don't flag my website as insecure. We have our own security mechanisms. We don't rely on HTTP. And I have to say that this is the only thing that I can do about it. Like, give a talk and tell people, that's not true. Your user data is exposed if you transmit anything over HTTP. There's no way you can reliably make it secure. There's no, no token generation mechanism is something that people often bring up. Nothing that you can do to replace the security mechanisms that HTTPS provides. So we kind of had to get a bit more radical, and that tipped off a lot more people. So this is what Firefox 52 now does when your login page is insecure. It says, logins entered here could be compromised if you focus a login field or a password or a username field. That's already pretty heavy, I would say, and we've gotten a lot of complaints around that. People are really freaking out around this. And we're not backing off because, as I mentioned, so far it's been pretty successful. Like the numbers are dropping, the numbers of insecure HTTP usage are dropping, and we're pretty satisfied. Another part of the story is that we now show, or we recently started to show warnings in the developer console when you're using these things. So if you're a developer and your website is insecure, you get one of these warnings. So for example, for mixed content, for insecure passwords, for weak signature algorithm, like recently SHA-1, you get a warning that, hey, you're using something insecure, please click it. And these are the most popularly clicked links that lead to MDN, and so that people can look up, what's wrong on my website and can, find docs how to fix it. And you can see that the most common ones are all related to HTTPS or, insecure HTTP usage. Those are the top 4. And so leading people to a website explaining that they need to upgrade to HTTPS, otherwise, their content is borked, isn't really nice. We need to present an alternative or a way for people to easily upgrade to HTTPS without, paying money. That's what Let's Encrypt is doing. It's getting a lot easier to obtain free HTTPS certificates, which is something that is vital for this whole story to work. There are still a lot of shared hosting providers and stuff where it's not as easy. A good example, which is actually preventing my website, my personal website, from working, is GitHub Pages with custom domain names. So that doesn't work right now, which is a shame. But it's getting more and more, and Let's Encrypt is definitely helping with that. There's also Cloudflare, which I wasn't even sure if I should mention it, because there are a lot of controversies around Cloudflare and how they use, or how they put themselves in front of your insecure page. But it's also an alternative if you can't use Let's Encrypt, for example. So, all right, I'm done, right? So this talk doesn't really have a lot of sense. I just turn on HTTPS. There's a lot more to do. So you can see that 2 of the most popular warnings are about mixed content. What is mixed content? Mixed content is basically when you have a secure page and you're linking to insecure resources from your secure page. So mixed passive content, which I would like to call the bad kind, is when you have an image resource, for example, any kind of static resource that is a link through HTTP, mixed active content is the really bad kind, and that is when you have dynamic content such as a script that can actually alter the content of your website. So let's start off looking at mixed passive content. So mixed passive content is fine, right? I mean, who cares if I have an insecure image on my website? What the fuck? Sorry. Nah. So this is this is from a talk which a colleague of mine, Luke Crouch, recently held, and he wanted to check the warning that comes up when you have mixed passive content on a website, and what he accidentally found. And I have to say that this is basically a random URL, so it's blocked out for security reasons. This is a random URL that he entered and wanted to check if they have mixed passive content. And this is a major internet service, well, not internet service provider, but like a major internet platform. And he found out that they actually deliver, so basically you actually have access to the cookie header in their mixed content images, obviously, right? Because the browser delivers that, which is really critical for their service because you can just copy the cookie and then just, log in. As being any website embedding that thing. That's kind of, not cool. And so be careful with mixed passive content. There's usually not a big reason to have it. Like, in my experience, it's usually easy to get rid of. That's how we flag mixed passive content. This is the warning. So you get a gray lock with a yellow icon, and you get a warning in the URL in the developer console. Mixed active content is actually pretty easy to avoid because browsers block it by default. So you get a green thing, a green log, and a warning that Firefox Developer Edition, for example, has blocked parts of this page. A good way to differentiate between mixed passive content and mixed active content is if you ask yourself the question, can it alter the DOM? If yes, then it's mixed active content, the really bad kind, but that will be blocked anyway. So just to summarize, please move to HTTPS. I'm sure a lot of you already have moved to HTTPS, but if you have a page or something, some resource that you're not sure of, should I move it to HTTPS? Just do. HTTP is for dinosaurs, and you know what happened to dinosaurs. They became cute comics. Right, so assume you have moved to HTTPS. You should consider turning on the so-called HSTS header, which is HTTPS strict transport security. That basically says, all right, for that length of time, I want my website to only connect through HTTPS, or I want the browser to only connect to my website through HTTPS. So if somebody, for example, explicitly types http example.com in their URL bar, they will still get routed to the HTTPS version because you said, really, I want this website to be routed through HTTPS. There's also, for example, an option to include subdomains, and that's a pretty good, reasonable defense against an attack called SSL strip, or a tool called SSL strip, which basically exploits the fact that you make a single HTTP connections to override all your web traffic. And that is pretty dangerous, and that's a pretty good security mechanism against it. Right, so we've made our connection secure. How do we secure our web content? So this is just a collection of techniques that modern browsers offer you. One thing is the same origin policy. It's not really a technique for you, but it's rather something that the browser automatically applies. So whenever you make a request to something from one domain to another domain that you don't own, then it says, or that the browser is not currently navigated to, then it says, sorry, we can't do that. This is also shown in this nice little graphic. Basically, you connect to one site, site A.com, and then site A.com in your browser wants to make an XML HTTP request to site B.com, but that doesn't work. So that's pretty annoying, but it has its uses. So what's affected by same origin policy? Why am I telling you this? So XHR requests are covered. Window.opener, window.parent are also covered. Although these are not requests, they're technically access to a different page. So in case you don't know window opener, window.parent, these are basically objects that you receive in a website accessible by JS when you were opened by another website. That means if you are in an iframe and if you have been opened by a different tab, you have access to these things. But only, or the access is restricted if the origin of the other page is different than your origin, which is also a good thing. However, there's one thing that is not restricted by same origin policy, and that is, for example, form with post method. Why is that lowercase? Anyway, so it's not protected. And that means you have to employ your own security mechanisms to not fall victim to basically websites embedding post forms to your website. They're just randomly changing things, or maliciously changing things. Randomly would be nice, right? So there's a mechanism called CSRF tokens for that, and also more stuff. I didn't have a link on this page. I will add it in the slides that are available online. So you should definitely read up on CSRF protection if you have websites that, or APIs that accept posts. Don't rely on cookies. That doesn't work. It's very easy to use to just say, okay, allow everything. You know, I'm in debug mode. I don't care. I'm just, you know, this is not production. And then at some point it just rolls into production because it works, right? And nobody really cares about it. And so please think about this from day one, or make a big to-do or something, that this is not a good thing if you aren't on a public API, and even then you should, you know, consider the options that access control or origin offers you. Oh yeah, if you didn't know, this is a header that you can set in your request, in your response, to basically say which origin is allowed to access this resource. All right. So another thing that you could, or that's really dangerous on the web, is XSS attacks. XSS is basically cross-site scripting. So an attacker injects something in your page, and that is not properly sanitized, and then that contains like a script that can run, and it completely breaks your website, and if you're really unlucky, it's persisted in some sort of database of yours, and then every one of your users sees it, which is really bad. A good general protection against this is called CSP. Now, I've heard a lot from people that CSP is like, I don't use CSP, that's overkill. And I don't know, I'm not sure. CSP, in my opinion, is a pretty good technology. It's just kind of a set of rules that define how a site may load resources. You can set it as a header on the server side, but since we're talking about JS, I just thought I'd show you how to embed it as a meta tag. And that's how you do it. So basically, you have this meta tag with a bit of boilerplate, and then the content attribute is the important thing. So here, for example, you say that by default, this is the required attribute, default source. All resources should only be loaded from this domain. Images may be loaded from HTTPS domains, and please don't use iframes. That's basically what you're saying. A cool side effect of content security policy is that it disables inline scripts by default, unless you specifically ask it to, which is a really bad idea. So any kind of XSS that injects an inline script is not really, well, it has a hard time because it can neither load an external resource unless you made a big mistake in your content security policy, nor can it execute its own script. There's a cool way to test what content security policy would break on your page if you set the content security policy report only header instead, which basically allows you to test it without breaking things by just logging everything that content security policy would have blocked if it were actually running. Related to that is another really cool feature of CSP. It allows you to record violations of the content security policy. So if you specify a report URI in your content security policy, you can set a URL where it would just send all violations to, which is, in my personal opinion, really cool. And there's even a service for that supports just you signing up and getting all these reports called reporturi.io, which is also awesome because you can even have it run in report only mode and just check what would have been violated, because websites can be pretty complex, so I can understand that. How can I make sure that the third-party content I receive has not been changed on the server? This is a common problem with if you have a CDN, for example. Well, it's not a common problem because most CDNs are pretty secure, but it's a problem that many people think about when they use CDNs. So how can I actually trust that the CDN is delivering me the right script, the right content? I've just, I'm downloading jQuery from one of these popular CDNs, but what happens to the internet if that CDN is compromised and jQuery includes malicious code now? That would be horrible. That's why a lot of CDNs on their homepages now, if you want to include things with a script tag, now include this integrity attribute by default. The integrity attribute on a script allows you to specify, hey, the original source that I looked at had this hash digest, basically, this hash. And I want to always receive contents with this hash in the future. If it doesn't match, dear browser, please don't allow it. And that's a pretty cool technology to prevent, it doesn't have to be the CDN even, but like prevent any kind of tampering with the original source that you were downloading. The cross-origin thing is, that's a CORS attribute for script tags. There's even a cool website called srihash.org, which you can just use to generate the hash easily. We don't even have to go into the command line or anything. Okay, so we've made our web content secure. Let's go another step up and talk about securing access to privileged device APIs, which is a relatively new thing, I would say. So there's only a couple of APIs right now. There device storage, there's some geolocation, web notifications, microphone, camera, pointer log, and the screen sharing. Sounds like a lot, but if you imagine the possibilities that devices like your computer or your phone have, there's still a lot to add. We could have raw TCP sockets, Bluetooth, USB, whatever. All these things sound pretty dangerous to just expose by default. If you just give a website your default permission to access the camera for any user, that's just really bad, because you could just record anyone without them really having a choice about it. So we need some kind of permission system for the web to allow users to have a choice whether they want the website to be able to have access to the privileged API or not. Unfortunately, so this is something that my team has worked on recently, and we found that the web platform wasn't really built with a permission system in mind, or it wasn't really ever built with the fact in mind that you can easily get access to a lot of limited technologies that can be very detrimental to the user privacy and security. And that kind of mirrors in how the spec is written usually. So it says user agent must acquire permissions through a user interface. Thank you. That's very helpful. And it's not really spec'd out how the whole permission thing works. So there are different ways, for example, to get permissions for different technologies. You can get camera or video, sorry, that's the same thing, camera or audio or screen share permissions by calling navigator.media devices get user media and just specifying what you want to have. This has lots of options, and then that returns a promise, and when the user allowed the permission, you get the promise back. Or the promise is not rejected. Then for notifications, that's a completely different thing, right? So you call notification.request permission, and then again, that's a promise. And geolocation doesn't even take a promise, or it doesn't even return a promise, but it just has a callback function which you can pass, and then you just get if there is if the user has said, okay, the website can have my geolocation. It's a bit inconsistent, but that's not even the worst part of it. The worst part is actually that there's not a consistent API, there just isn't, to get information about whether you already have permission or not, so for example, I think for geolocation, there's no way to do that right now except using the permissions API, which is like a draft that is only implemented by Firefox, and it was at some point implemented by Chrome, but I'm not sure if they pulled it or not, because it's not very popular and it's not really gaining traction, which is a bit of a shame. And something that we as browsers, I think, should work on. So it also, the UI for it is also kind of different. So this is actually something that we worked on recently to get Firefox in line with the other browsers in terms of UI. So if you as a website request a permission right now, expect your users to have really different experiences around different browsers. So currently, this is actually not accurate for the screenshot on the very left is the screenshot for Firefox, and that's actually not accurate right now for 51. That's coming in for 52. That's coming in 53, which is out in a couple of weeks. And the old version was, for example, not modal. So we converged them to be all modal in that the user can't dismiss them. In the old Firefox, you could dismiss it, and then the website would just forever wait on the callback or the promise to arrive, and not at any point get a rejected promise if the user just dismissed it. It's very different around remembering permissions. So you have to be really careful if you request a permission that it's a pretty good permission request, because most browsers are pretty strict about if you can ask a second time. Firefox has this concept of temporary permissions now, which basically blocks a permission for the duration of the tab lifetime until you navigate away, so that websites don't continually spam with a permission request. Hey, you sure you don't want to get notifications? Okay, you said no again, please, please. And Safari and Chrome are, for me personally, a bit harder to understand, but they do similar things. Like if you continually ask for permission, it doesn't work. Like you can't just spam the user with permissions, which is a good thing, because permissions have been pretty annoying recently. So there are, the features that are exposed to permissions are super powerful. That's why malicious websites have a big interest in getting these permissions and are employing tactics to basically get the permission from the user, eventually by just nagging them or through tricking them into clicking it. So one example of this is if you have such a permission prompt, a website in Firefox used to spawn a window on top of the permission and have a click target approximately where the OK button is. That actually happened. And then when the user hovered it, it went away. And then I don't know, some people probably instinctively clicked it and then they granted the permission and then they found the geolocation. I don't know why the website was doing that, but we had to implement a fix that basically as soon as the window is focused, the window that spawned the permission prompt is focused, the permission prompt can't be clicked for like 2 seconds or something. So there are a lot of abusive permission prompts, and that's why browsers will start to penalize intrusive and surprising permission prompts. So Chromium has an intent to implement, I think that's a link to intent to implement blocking permissions after you denied for the 3rd time, completely, like permanently, for your website. And the bug that is linked there from Firefox is the concept of implementing temporary permissions to block when you've already said no. So this is a really bad example, just to give you a really bad example of how you shouldn't do things. This is basically T-Mobile, the T-Mobile homepage, which as soon as you browse it, offers you, hey, can T-Mobile.com access your location? And you're like, I think they use it for their store search or something, but you're like, why? Why would you do that? And it's pretty obvious that most users will either say no or will be confused and say yes or something, which is also not something that we want. So there is work to prevent this stuff ongoing, which would probably look like the following. If a user did not cause an action, for example, click a button, you may not spawn the permission prompt. So we call it is handling user input. Basically, that prevents spawning things right away, and it also prevents spawning without any user interaction. It's only, it's a limited kind of check, but at least you can prevent this stuff from happening. So a good technique to get proper permission from users is to pre-prompt. Pre-prompt gives the user context. It tells them, hey, here's this message, but we would really like to be able to alert you in the future when you receive more messages. Would you like to us to be able to notify you on your desktop whenever your browser is minimized or closed or whatever. And the user then is much more able to make a conscious choice about allowing or not allowing the permission prompt. So this is a good example. Slack, I think it's a pretty good example. So Slack says, Slack needs your permission to enable desktop notifications. If you click the X, they don't show this thing again. If you click on enable desktop notifications, they show the permission prompt. Or they ask the browser to show the permission prompt for them. Another good example is WhatsApp Web. They do that in a similar way. Notifications are usually a pretty good example of this. So they say, you can get notified when you get new messages, click here, and then they show the permission prompt, and the user can then make a choice. And I think it's no coincidence that these two companies do that. I think their user testing revealed that this results in a much higher rate of acceptance from users too. So do it for yourself, because you want your users to accept your notification permission prompts, but also do it because browsers will likely force you to do it. So another thing that we will probably do soon around web permission prompts is restrict permission prompts from iframes, because iframes are nasty to manage in browser UI. So what if so browser UI is pretty limited around security. So you want to put it in the main UI of the browser, but you only have so much space in your browser Chrome. So and you don't want to pack it with all the details around all your iframes that you've embedded around permissions and whether they can open pop-ups and whatever. So a rather easy solution to this is to just say, iframes can spawn permission prompts. And if I were you, and you are, for example, running a notification service, embedding it with an iframe, please ask them to migrate away from iframes, because Chrome will soon deprecate it, and we're also thinking about it. All right, yeah, this is the classical, with great power comes great responsibility. Web permissions and device capabilities is a really dangerous thing, but it can also be used for great things like WebRTC, live chat, screen sharing, and location access. All right, that kind of concludes the, oh wait, okay, these pages are completely broken. So that kind of concludes our tour around secure websites. Just to give you another quick summary of what we talked about. So I would really like to ask you to make sure that all your connections are secured through HTTPS. Please take care of your mixed content, because that's also really dangerous and may break your websites. Set an HSTS header. Be wary of cross-origin restrictions when developing, and be wary when allowing cross-origin access to your own APIs. Have a CSP just to deny the inline script. Nobody should have inline scripts nowadays. Just to deny your inline scripts on your website, have a CSP. This is for some reason, the rest is not displayed. But another thing that you should absolutely do is, well, yeah, basically, what did we talk about? Does somebody remember? Well, more stuff. Secure access to device capability, we talked about this. Basically, browsers are limiting the way that websites can access device capabilities, and you should be careful when asking for permission, because browsers are much more restrictive, or will be much more restrictive, thinking about the user experience, and users are much more prone to deny if you don't give proper context in your warnings. All right, that's me. I work for Mozilla, and you can ask questions. Go ahead. Yeah, go ahead. Right. So this is planned. Like, all this is planned. It's not. I work from Mozilla, but it's not an official statement of intent from the Firefox team. Okay.